Welcome to this Concept Explainer, brought to you by CBSE ScoreLab of ProfSam.com. Today, we're going to tackle a topic that is the absolute foundation of your Class 12 physics.
That's right. If you're a Class 12 student, you really cannot escape this one. We're starting Unit 1, Electric Charges and Fields. And specifically, we're doing a deep dive into the concept of electric charge.
See, many students get confused in the basics. They'll memorize the formula, but they don't really feel the concept. But today, we will clear the concept of charge so nicely you will never forget it in the exam. Simple, exam-safe explanation. Okay.
That sounds perfect. Because honestly, when I look at the textbook, sometimes the definitions feel a bit heavy. I just want to understand it so I can solve the questions.
Don't worry, we will decode everything. So let's start with a simple question from everyday life. Have you noticed in dry weather, especially in the winter, when you take off synthetic clothes or a sweater, you hear a crackle sound?
Oh, definitely. It happens all the time. Actually, if the room is dark, I've even seen a small spark, like a tiny blue flash.
Exactly. It's like a mini lightning storm right on your body. No, it's not just friction. It's something fundamental happening.
And what about that classic trick, the comb and the paper pieces? You know, when we comb dry hair and then bring the comb near the paper just jumps up and sticks to it. Why does that happen?
That is the big question. And think about what's happening there. The paper piece is jumping UP. That means this invisible force from the comb is pulling it harder than the entire Earth is pulling it down with gravity.
Wait, that's actually crazy when you put it like that?
Right.
You mean that small plastic comb is beating the gravity of the whole planet?
Yes, that is how strong this force is. We call this electric charge. But wait, here is the twist. This force is very, very sensitive to distance. If you double the distance between that comb and the paper, the force doesn't just become half.
It becomes less.
Much less. It becomes 1/4.
1/4. Wow, that's a huge drop.
It is, and we'll see exactly why that happens when we look at the formulas. But first, let's build a mental picture. You can't see charge with your eyes, so how do we even think about it?
Right. The insert book says it's a fundamental property. But what does that actually mean? Is it something inside the particle?
Think of it like this. You know mass. Mass is a fundamental property. You don't ask, what is mass made of? Mass is the property. In the same way, charge is the property. You don't ask what it's made of.
Okay, so it's a built-in feature. Like how red is a property of a rose. You can't really separate the red color from the rose itself.
Correct. But to visualize it for the exam, I want you to imagine a little story. Imagine every tiny particle in the universe is wearing an invisible badge.
A badge. Okay, like a name tag or something.
Exactly, an invisible badge. Now, in nature, there are 3 types of particles we care about for now. First, the protons. Protons are wearing a badge that says positive, a plus sign.
Okay, so protons are walking around with a positive badge. Got it.
Then we have the electrons. They're wearing a different badge, one that says negative, a minus sign.
And what about neutrons? I see them mentioned here too.
Neutrons are the quiet ones. They are wearing no badge at all. They are neutral. Now, these badges, they determine how these particles behave when they meet each other.
So what are the rules? Do they fight or are they friends?
The rules are very strict. If 2 particles meet and they're wearing the same badge, like positive, positive, or negative, negative, they hate each other. They just push each other away. We call this repulsion.
Like 2 rival teams. Or maybe like the north poles of 2 magnets.
Exactly like magnets. Same types repel. But if the badges are opposite, one positive and one negative,
then they attract.
Yes, they pull each other closer. Attraction.
I see a note here. It says, like Romeo and Juliet, opposites attract.
Yes, that's the one. Opposites attract, and like enemy armies, same types repel. This is the golden rule. If you remember this, half your problems are solved.
Okay, but I have a doubt. You said neutral particles have no badge. But what about a neutral object? Like a plastic pen before I rub it. Does that mean it has no badges inside it at all?
See, this is where students make the biggest mistake. A very, very common confusion. No. See, neutral for an object does not mean it has no badges. It just means it has an equal number of positive and negative badges.
Oh, so they just balance each other out.
Precisely. A neutral body is full of charges. Billions of protons, billions of electrons. But for every positive badge, there's a negative badge canceling its effect. So neutral means balanced charge, not zero charge.
That is a very important distinction. I think many of us assume neutral means empty.
Never empty, it's just balanced. Now let's see how NSERT defines this technically, because in the exam you can't just write about invisible badges, you know. You need the scientific definition. Can you read the definition for the quantization of charge from the book?
Sure. Let me read it exactly as it is. It says, experimentally, it is established that all free charges are integral multiples of a basic unit of charge denoted by E. Thus, charge, Q, on a body is always given by Q equals NE. That sounds a bit complicated. Integral multiples. What's that?
Okay, let's unpack this. This is called the quantization of charge. It sounds scary, but the logic is very simple. Think of students in a classroom. Can you have half a student in a class?
No, obviously not. You could have one student or two or three. Whole numbers.
Exactly. You can't have 1.5 students. Students are quantized. In the same way, charge comes in packets. The smallest packet is 1 electron. You can have 1 electron, 2 electrons, 100 electrons, but never 1.5.
I get it. So the smallest possible packet of charge is just the charge of a single electron.
Correct. And that value is extremely important for numericals. We denote it by the letter E. And the value is 1.6 into 10 to the power minus 19 coulomb.
And coulomb's a unit of charge, right? Capital C.
Yes, coulomb, capital C. So the formula is Q equals NEQ, is total charge. N is an integer like 1, 2, 3, or minus 1, minus 2. And E is that basic charge value. So if I ask you, can a body have a charge of 2.5 times E? What will you say?
I'd say no, because 2.5 is not an integer. You can't have 2.5 electrons.
Perfect. You've understood quantization. Now, before we move on, I just want to check in. Hope everything is clear so far. This concept explainer is from ProfSam.com. That is PROFSAM.com.
Okay, so moving on. We talked about badges and packets. What about that rule that charge can't be destroyed? I've heard something called conservation of charge.
Yes, that's a second big law.
Yeah.
It simply means that charge is not created or destroyed. It is only transferred.
Is this like money in a bank?
Perfect analogy. Imagine you transfer 500 rupees from your bank account to your friend's account. The money didn't vanish, and it wasn't created out of thin air. It just moved from account A to account B.
So the total amount of money in the whole banking system stays the same.
Exactly. The net amount is conserved. So when you rub a glass rod with silk, you are not creating charge. You are just transferring electrons from one to the other.
So the glass becomes positive because it lost the negative badges, the electrons.
Yeah. And the silk becomes negative because it gained them. But if you add up the new charge of the glass and the silk, the total is still exactly 0, just like before you rubbed them.
That makes a lot of sense. Now, you mentioned earlier that the force is huge and depends on distance. Can we discuss that formula? All the numericals come from there.
Yes, this is the heart of the chapter, Coulomb's law. It tells us exactly how strong that push or pull is.
What's the equation we need to write in the exam?
The equation is F equals K times Q1, Q2 divided by R squared.
Okay, let's break that down. F is force.
Yeah.
Q1 and Q2 are the two charges.
Right. And R is the distance between them. Now look closely at the bottom. It's R squared. This is the famous inverse square law.
This reminds me of the gravitation chapter from class 11. Newton's law was also inverse square.
Exactly. It connects directly to your class 11 concepts. If you double the distance, so you move the charges 2 times farther apart, the force becomes 1/4 because 2 squared is 4.
And if we triple the distance, it becomes 1/9.
You got it. The force drops off very, very fast as you move away.
And what about that K in the formula? Is that just a constant?
Yes, it's Coulomb's constant. For vacuum or air, its value is very large. 9 into 10 to the power 9. That huge number is why electric forces are so much stronger than gravity.
So we try a quick example, just to see how the numbers work. I usually get stuck with the powers of 10.
Yes, let's do a simple one. Suppose we have 2 small spheres. Each has a positive charge of 2 into 10 to the power minus 8 coulombs.
Okay, both are positive, so they will definitely repel each other.
Correct. And they are placed 10 centimeters apart. First step, and this is where students lose marks, we must convert centimeters to meters. So 10 centimeters is 0.1 meters.
Right. Always use SI units.
Always. So the formula is F equals 9 into 10 to the power 9 times 2 into 10 to the power minus 8 times another 2 into 10 to the power minus 8, all divided by 0.1 squared.
That looks like a lot of numbers. How do we solve it?
We group the numbers and group the powers. First, the plain numbers. 9 times 2 times 2, what is that?
Let's see. 9 times 2 is 18, and 18 times 2 is 36.
Perfect. 36. Now, for the powers of 10, we have 10 to the power 9 minus 8 and another minus 8. So that's 9 minus 16.
Which is minus 7.
Mm-hmm.
So the top part is 36 into 10 to the power minus 7.
You're getting it. Now the bottom, 0 0.1 is 10 to the power minus 1. So squared, it becomes 10 to the power minus 2.
Okay.
Now we divide. When you bring that 10 to the power minus 2 from the bottom to the top, its sign flips. It becomes plus 2. So you have minus 7 plus 2.
That's minus 5. So 36 into 10 to the power minus 5.
Almost. In physics, we like to have one digit before the decimal, so we write it as 3.6 into 10 to the power minus 4 newtons.
3.6 into 10 to the power minus 4 newtons. It is a small force.
It is, but the charges were tiny. If these were 1 Coulomb charges, the force would be enormous.
That really helps. Now, apart from calculations, what are the other silent killers? The concepts that seem easy but trick us in the exam.
Ah, the silent killers. The first one is confusing mass and charge.
We said they both fundamental properties, so how are they different?
Well, mass is always positive. You can't have negative mass, right? But charge can be positive or are negative. And here is the big one that most people don't know. Mass actually changes with speed.
Wait, really? Mass changes with speed.
Yes. Einstein's theory of relativity. If you run very, very fast near the speed of light, your mass increases. But charge is invariant.
Invariant. What does that mean?
It means it does not change no matter what. Whether an electron is sitting still or moving at 99% of the speed of light, its charge is exactly the same. The value of E is fixed.
Wow. Okay, charge does not change with speed. I need to remember that. What's the second misconception?
The second one is thinking uncharged means empty. A student sees a neutral sphere in a diagram and thinks, oh, it has no electrons.
Right, but we know now that it's actually full of electrons.
Yes. If you write, it has no charge in the exam, you get 0. You must say it has an equal number of protons and electrons. It's electron-rich, just balanced.
So uncharged means balanced, not empty. Got it.
Now, to help everyone remember these properties, we need some memory anchors. A mnemonic.
I love these. They really help during revision. What do we have?
A simple one, QUAI. Just remember the letters QUAI.
Okay, QUAI. What does each letter stand for?
Q is for quantized. That's the packet rule. Q equals NE.
Okay, Q is quantized.
U is for unchanging total. That's conservation.
Okay, conservation.
A is for additive. If you have plus 5 charge and minus 3 charge, you just add them. 5 minus 3 is plus 2. Simple.
And I?
I is for invariant. It doesn't change with speed.
QUAI. Quantized, unchanging, additive, invariant. That's very handy. Do we have a gesture to remember the force direction?
Yes. This is great for visualizing the electric field later on. Use your hands, make a fist. If it's a positive charge, open your fingers outward like an explosion. Positive means the field goes OUT.
Okay, so I'm pointing my fingers away from my hand, fingers out for positive.
Exactly. And if it's a negative charge, point your fingers inward, towards your palm. Negative means the field comes in.
Fingers out for positive, fingers in for negative. That's a great visual.
And always remember that phrase, opposite charges attract like Romeo and Juliet. So we've covered a lot today. Let's summarize this into 3 exam-safe points. If you're making notes, write these down.
Okay, ready. Point number 1.
Point 1. Electric charge is a fundamental property. It comes in 2 types. Positive, which is the proton, and negative, the electron.
Point number 2.
Point 2. Charge follows strict rules. It is quantized, meaning Q equals NE, and it is conserved, meaning the total charge in an isolated system is constant.
And the final point.
Point 3. The interaction follows Coulomb's law. Like charges repel, unlike charges attract. And the force is inversely proportional to the square of the distance. Remember that 1/r² rule.
That sums it up perfectly. We've gone from the sweater crackle all the way to Coulomb's law.
Exactly. And there is so much more in this unit, like electric fields and Gauss's law, which we will cover. But if you understand this foundation, you are safe. To get maximum marks in 12th CBSE Physics, Chemistry, and Maths, visit ProfSam.com.
That's PROF Sam, right?
Yes. Study hard, and we'll see you in the next deep dive.